We are multiplying and dividing rational expressions. So let's get a good understanding of when we can cancel. In this first fraction, this is 3 times x over x. Hopefully you remember from previous work that the x's will cancel. The answer is 3. But in this problem, x plus 3 over 3, that is not x in the numerator. That is not 3. That is x plus 3, a binomial. Your answer is x plus 3 over 3. Those 3's will not cancel. Let me explain it with numbers. Okay, if I have 10 over 2, don't worry, I know that you know it's 5. I'm doing this a long way on purpose. 10 is 2 times 5. I could factor that. 2 times 5 over 2. And yes, that's 2 times 5, not plus 5. 2 times 5. Those are the factors. The 2's will cancel. The answer is 5, just like you knew we were going to get. You were able to separate these when they were connected with multiplication. Notice this. If I have 7 over 2, 7 is 3 plus 4 over 2. Would you, could you, should you cancel the 2 and the 4? 2 will go into 2 one time, 2 will go into 4 2 times. It looks as if 3 plus 2, it looks as if it would be 5 over 1. But 7 over 2 is not 5. 7 over 2 is actually 3.5. You cannot cancel this 2 and this 4 because 3 and 4 are connected with a plus. But why could I break this down and cancel out those 2's? These are connected with multiplication. Okay, I'm about to do something corny, so don't tell my kids. Okay, here comes my corny thing. 3 times x divided by x. We have already talked about this being 3 times x, and yes, I could cancel out these x's and get just 3. Okay, the way I think about multiplication, these two terms have only been on a couple of dinner dates. You can break them apart. It's okay. Okay, but if we have two terms connected with a plus or minus, that plus or minus is like a wedding ring. They are married. Do not separate them. You see my little wedding ring connecting them? Ooh, look. And we can make it big. So, you cannot separate it if it's a binomial, if it's connected with a plus or a minus. So that is my corny thought for today. Hopefully you will not forget it on a test, though. And the last thing I need to make sure that you know and you are good at, I have an x minus 5 over 5 minus x. These are not the same. They will not cancel. If I had x plus 5 over x plus 5, yes, these will cancel out, just leaving me 1. If I had x minus 5 over x minus 5, yes, these will cancel out. They are exactly the same, just leaving me 1. If I had x minus 5 over x plus 5, these are not the same. I have a positive x and a negative 5 in the numerator. In the denominator, I have a positive x and a positive 5. Those are not the same. Your answer is x minus 5 over x plus 5. It did not cancel out. And then we have this situation. I have x minus 5 divided by 5 minus x. Well, eventually I want you to learn that the answer here is simply not 1, it's negative 1. In the numerator, we have a positive x and a negative 5. In the denominator, we have a positive 5 and a negative x. Exactly opposite. And that's why they will cancel out, but they don't leave you 1, they leave you negative 1. Let me prove that to you. In the numerator, we have x minus 5. In the denominator, watch this. I'm going to factor out the negative 1. Negative 1 times a negative 5, that's still positive 5. Negative 1 times a positive x is still a negative x. So my denominator is still the same thing. Now let's rewrite this. And in my parentheses, instead of a -5, positive x, I'm just going to switch those around. But notice I kept my x positive, I kept my 5 negative. And now look, the numerator and the denominator will cancel. But I do have a -1 left. So I want you to notice when you have binomials that are completely opposite. In the numerator I have positive x and a -5. In the denominator I have a positive 5 and a negative x. They will cancel somewhat, not completely. But when I cancel them out, I do need to put up here -1. Okay, here we go. We have 4x over x squared minus 4 times x plus 2 over 16x. We are multiplying and dividing, so I just cancel out what I can. But you may have to factor first. In the first fraction, I do have 4x, that is 4 times x. In the denominator, x squared minus 4, hopefully you recognize that as the difference of two squares. That will be x plus 2 times x minus 2. And this fraction is multiplied by x plus 2 over 16x. I have factored completely, so let's see what cancels. Remember, anything can cancel as long as one is in the numerator and one is in the denominator. Okay, the x plus 2, that is exactly the same as this x plus 2. Positive x and a positive 2 in both places. Those will cancel. This is 4 times x. Yes, they're not married. I can separate that x. These x's will cancel. This 4 and this 16, they will cancel. 4, we're going to both of those. So 4, we're going to 4 one time, and 4, we're going to 16 4 times. Let's see what I have in the numerator. It looks like it's only 1. In the denominator, it looks like I have 4 and x minus 2. So 4 times x minus 2. Make sure your teacher is okay with you leaving it factored, but if she wants you to multiply that out to 4x minus 8, make sure you do so. Okay, 4a plus 8 over a squared minus 25 times a minus 5 over 5a plus 10. We have lots of factoring to do. In the first numerator, it has a GCF of 4. When I pull that out, I will have 4 times a plus 2. In the denominator, a squared minus 25, that is the difference of two squares. That will factor into a plus 5 times a minus 5. That is multiplied by a minus 5 over. In the denominator, I'm going to pull out the GCF of 5, and that will leave me a plus 2. Now, if you are having trouble factoring, I do have several videos on factoring that could help you out, because you have to know how to factor in order to do these problems. Well, let's start canceling out. The a minus 5 will cancel with the a minus 5. The a plus 2 will cancel with this a plus 2. It looks like that's it. The answer is 4 over, in the denominator, it looks like I have 5 and a plus 5. I like to write the monomial first. So 5 times a plus 5. Let's try another one. I have x plus 5 over 3x times 12x squared over x squared plus 7x plus 10. My first fraction will remain the same. There is no factoring needed. My second fraction only needs to be factored in the denominator. X squared plus 7x plus 10 will be x plus 5 times x plus 2. Okay, let's start canceling. The x plus 5 will cancel with this x plus 5. Now, this 3 times x, yes, you can separate that 3 and that x. They're only connected with a multiplication. This is 12 times x squared. Well, 3 and 12 will cancel. 3 we're going to 3 one time. 3 we're going to 12 4 times. The x and the x squared will cancel. Hopefully you remember from your monomials that will just be x to the first. If it makes you feel better, this x squared is the same thing as x times x. So I need to move that because I rewrote it. And the x will cancel with one of the x's. Hopefully I did not get this too messy. In the numerator, I have 4x. In the denominator, x plus 2. Okay, will the 2 and the 4 cancel with this x and this x? I could separate the 4 times x in the numerator. But in the denominator, that is not x, that is not 2, that is x plus 2. No, you can't separate those. You are done. One more problem to go. And would you look at the factoring needed? In the first fraction, x squared plus 3x minus 10, I will factor that into x plus 5 times x minus 2. In the first denominator, x squared plus 8x plus 15, I will factor that into x plus 5 times x plus 3. Remember, it does not matter which order I write these binomials. That is divided by, in the numerator of the second fraction, x squared minus 6x plus 8, that will be x minus 4 times x minus 2. Ooh, I have to be careful with this denominator. It's written a little differently, but don't let that scare you. I know to get this x squared, it's a negative x squared. So I have to have a positive x times a negative x. To get 12, I will use 3 and 4, but I want the 4 to be positive. So I will actually have to put that 4 in the middle there. Let's check that. First term, 3 times 4 is 12. Perfect. Outer is a negative 3x, inner is a positive 4x. I will get 1x in the center, middle term, and an x times a negative x is a negative x squared. But wait a second, this is dividing. It is not multiplying. Well, we still divide just like we did in 5th grade. Instead of dividing by a fraction, you multiply by the reciprocal. Do you see this second fraction? I did switch the numerator and the denominator. Okay, I am ready to cancel. X plus 5 and this x plus 5. Yes, they will cancel. This x minus 2 and this x minus 2. Yes, they will cancel. Now I have 3 plus x and x plus 3. Are those the same? I have a positive 3, a positive x in the numerator, a positive x and a positive 3. Yes, they are the same. Even though they're not written in the exact same order, the signs on both terms are the same. So they will completely cancel out. And then I have 4 minus x, and I also have an x minus 4. Those are not the same. Are they completely opposite? Well, I have a positive 4 and a negative x in the numerator. In the denominator, I have a positive x and a negative 4. Yes, they are exactly opposite. What does that mean? That means that they will almost cancel. I can cancel them, but I have to make sure that I know they don't cancel out completely. I would have a negative 1, not just 1. What's the answer? It looks like I only have a negative 1. Wow, that was a huge problem to end up with simply a negative 1.